Hello students, in this lecture we will be talking about Cauchy's integral formula. According to Cauchy's integral formula, uh, if there is a closed region C in the complex plane, this is the real Z, this is the imaginary Z, and the function fz is analytic inside and on C, then we can say that f z0 for any point inside this contour is equal to 1 by 2 pi I C fz z minus z0 tz. This is the Cauchy's integral formula. Now we will take some examples to find out the applications of this formula. For example, if we have been asked to compute e to the power z square divided by z minus 2 tz, where the contour C is the following. Contour C is like this, and there is a point 2 here. So now this point indicates that the function fz is equal to the power z square z minus 2. So if you put z is equal to 2, the function becomes not defined. I mean, it becomes e to the power z square minus 2 minus 4 becomes 0. So this point z is equal to 2 is called a singular point. So the function is not analytic at z is equal to 2. So therefore, if we say f2 and if we put it in the Cauchy's integral theorem, then it will be f2 into 2 pi I will be equal to 2 pi I into e to the power 4, because z square at 2z is equal to 4. So this is the solution that we obtained by using the Cauchy's integral formula. Now, if the contour C was not holding the singularity. It means it was like this, imaginary z, real z. This is the point 2. If the counter C was like this, not including the singular point, then it implies that fz is analytic inside and on C, because there is no singular point which can fz here is of course e to the power z square z minus 2, and from Cauchy's integral theorem CIT we know that if a function is analytic inside a contour, then fz dz is equal to 0. From there we can say that the integral e to the power z square z minus 2 is equal to 0 for this x. Now the next thing is the derivative of a function. So we can write the derivative function of a complex function as f and z with nth derivative, and it is given as n factorial divided by 2 pi I c, and write it as f omega divided by omega minus z to the power n plus 1 d omega, where n can take any values from 0, 1, 2, 3. This is the n derivative of a complex function. Now, based upon this formula, we can actually solve some of the integral problems. For example, if there is a problem to solve the value of this integral e to the power 2z divided by z to the power 4 dz, where the radius of this contour is z is 1, then we can say that if we put fz is equal to e to the power 2z, then we can write the integral is equal to 2 pi I divided by 3 factorial, because this z is 4, so 4 is basically n plus 1. to f sorry f 3 factorial third derivative 0. So why I am using 3 factorial? Because this 4 is basically this n plus 1, so that is why n becomes equal to 3. So it's n 3, so here becomes 3 factorial becomes here, and 2 pi I, so this goes to here. So this is what is happening, 2 pi I into f factorial. So this becomes f 0 into 3 factorial, 2 pi I by 3 factorial. So that is how this comes, and this becomes equal to 8 by 3 into pi I. So this is the answer of the integral.